So in this video, we're going to be talking about inheritance and casting. If you don't have that much time, then the code link will be in the description below. I'm also going to link a resource that I found helpful in learning casting and inheritance from the C++ standard library. Not standard library, from the C++ website. So let's start off with motivation. Okay, so now why are we using inheritance to begin with? We find that memory management in C++ takes up a lot of time and is a big resource killer in terms of like in terms of a C++ project. Now, a lot of languages other than C++, they implement their own garbage collection. So like Java, for example, has its own garbage collection to eliminate the use of allocating memory for some variable and then having the need for the developer to deallocate it. C++ doesn't do that. You allocate your own memory and then you have to manually deallocate it. With the use of an inheritance, what it gives developers the ability to do is that they can allocate memory for some child class and they can manage the memory in its parent classes. Frameworks such as Unreal Engine and as well as Qt, they implement this model. In Unreal Engine, they use the U object to manage memory for child classes. So for example, these could be the child class, and then you have some parent class called a U object, which aims to essentially just manage any memory leakages. The second is that it gives developers more functionality without having them to write a lot of boilerplate code. So in this case, I took a picture of a random project, and you'll see in here that when you drag something from the developer panel to the viewport, you'll find that it has to do a bunch of things to get it to work. Namely, it has to get it to render in the engine. It has to remember if there's any animations, or reference any animations. It has to make sure that physics is correct. There's a lot of functionalities. It also has to serialize the data. So there's a lot of functionalities that it has to do in order for it to get it to work the way you intend it to be. If there was no inheritance, it would be a pain to do this over and over and over again for each character or each component that you create. Yeah, so it can be extended by the developers, and then sometimes it better describes the system. So the design I'm going for in this video, the class hierarchy, if you will, I'm going for in this video is going to be as follows. First, we're actually not going to create, but instead, I kind of already designed a layout of how this system will work. So let's just go through that. So in this part here, I have a location, and that's described by this piece of code here. And in this part, I have an animal parent class. So this is kind of the parent class of all child classes in our design model. So we have our animal class, and then we'll notice that the mammal inherits from the animal, and we'll notice that the bird also inherits from the animal. The animal inherits from the animal, or the mammal inherits from the animal, the bird also inherits from the animal. The way we are able to denote this in C++ is that we use a colon operator and then followed by the specifier public. And that's how we say, okay, you will inherit from this class. I've been throwing the term inherit a lot in the past 2 minutes, but what does inheriting actually mean? So if I were to create something such as, let's say all animals have a location. So start location. Okay. And let's say the start location is 0, 0, 0. And then we can override this in the child classes. So I want to make this protected. And the reason I'm making it protected is because I want this member to be shared across the mammal class. But in addition, I also want it to be shared across the bird class. And not shared is not the right term, but rather it inherits it. So what does that mean? So if I were to create a public class and I say a location, get location. And all that does is it returns the start location. So now in main, I'm actually gonna use, so everything in main is gonna be me using the classes that I created. So I'm gonna create an animal class. And so we're just gonna say random animal. And then we're just gonna say new animal. So new returns, allocates memory and returns a pointer to that piece of memory on the heap. And so for that, that's why we have to make this of type animal pointer. Now we take the random animal, and what we're gonna do is we're just gonna call one of its functions. So in this case, I'm gonna call the get location. And I wanna print that, so I'm gonna do an stdc out. And in here, I'm just gonna do a new line as such, okay? And the reason it's complaining is because I'm calling get location and it's saying, I don't know what a location is, but then we know it can print these specifically. So I'm gonna say get location.x, for example. I could do it for each member, but I'm not going to. I'm just gonna do it for one of them. So now it printed out 0. And to be a little bit more descriptive, I'll just say start location. And then run that. And then we see the start location of the animal is 0. So now what I'm going to do is I'm just gonna take the mammal class and I'm gonna say, what's a mammal? Let's see what, I'll just prefix it with random and then followed by the name. So you could give it any name, but I'm not good with names. So I'm gonna default to this. Okay. Now, if I were to print this out, start location of mammal in here. And now I take random mammal and then I call get actor or get location. We'll find that it will say the start location for the animal will be 0. That's here. And then the start location for the mammal will be 0. So what do we notice in this piece of code? We notice that in the mammal class right now, it's empty. But because the mammal class inherits publicly from an animal, that means any functionalities that are part of the protected section, so this, and any functionality that's part of the public section, which is that, will be sort of absorbed into the mammal class. It's going to take it into the mammal class. So this functionality, although it's not written here, it physically is there. Like this is in the mammal class. So it eliminates the usage of code duplication, because otherwise you would have to do this for each mammal that you wanted. If you wanted all the animals in your game, for example, to have a get location, it's easier to just have that in the parent class and then just call that from the parent class, rather than calling it for making get location for each one of the child classes of animal or of actors or whatever parent class you have. So now we have get location, and what I'm gonna do is I'm gonna do a print string. So I'm gonna give mammals their own print string. So I'm gonna say, what can mammals do? Let's say they can howl. Howl. I don't know if I spelled that right, but it doesn't matter. And then okay, so let's say mammals can do that. So this is a functionality that's specific for a mammal class. So now if I make a wolf and Ken the wolf, now we'll notice that if I run this, we notice with our wolf Ken, what we can do is we can definitely call the howl class. The reason we can call it is because, there we go, howl, void, there we go, declared. Okay, so the reason it was complaining is because this should either be marked as public or protected, because otherwise I can't access it outside of the class. Okay, so we know it says start location animal, and then mammal, and then we have Ken and his howling. So it's calling this function, howl howl. I'm gonna put a new line here. We also notice that Ken can do another thing as well. We can call his get actor location. There we go. And we can format this to be the same as the previous one. There we go. And now Ken has two functionalities. He has his howl howl, which is something he inherited from the mammal class, but he also has his start location, his get actor location, which is something he inherited from the animal class. The takeaway of this hierarchy in here is that the class at the very bottom will have the most amount of functionalities. And the reason that's the case is because the class at the very bottom is taking functionalities from the class at the top, and the second class is taking functionalities from the first class. So that means everything in these two classes here is being adopted into this last class. Yeah, and so we talked about that. I want to now transition into assignments. So if I go, and this is going to be like assignments. So what's the significance of what we just did? We have a bunch of animals. We know that an animal can be assigned to an animal. We know that's true because of line 38. We know a mammal can be assigned to another mammal. That's true because of line 40. We know that a wolf can be assigned to another wolf, which is true in line 42. To really show what's going on, I'm going to have to make two functions. So in the mammal class, or in the animal class actually, I'm going to have to make a string, or it doesn't have to be a string method, but I'm just going to make it a string because it's easier that way. And I'll just call it morning routine. And in here, I'm just going to say the morning routine of an animal is to fart. I created this function, so we know for sure that we can call this function in the mammal class. If I go to the mammal class, and then I say random mammal, and I say morning routine, we'll notice, let me put a new line, just, there we go. So we'll notice it says start location, and then it says fart. Okay, perfect. So now what if I were to take this function and then just paste it into the mammal class? And then instead of a mammal farting, they're gonna P. So now we have these two functions. And what we're gonna, so now if I go to the mammal class, so I know this is a mammal. So now if I call this, before it was calling fart on the mammal, but now if I run this again, we notice it instead calls P in here, morning routine. But then if I call the animal class, the random animal, and I call a function in there, and then I call the morning routine on the animal class, and I run this, we notice it calls fart for the animal class. Now this is the tricky part. So let's say I made an animal, and then it's going to be a mysterious animal. Can I spell mysterious? Let's say it's a messy animal. And let's say I said that messy animal, so that the messy animal of type animal is in fact a random mammal. Let's just say that, okay? And now if I run this, okay, so I assigned it, and then it didn't crash, it didn't do anything. It just was able to assign it. And the reason it was able to assign it is because a random mammal, it seems that it wouldn't be able to work, because an animal can be assigned to an animal. That makes sense. A mammal can be assigned to another mammal. That also makes sense. But how is it that an animal can be assigned to a random mammal, which is in fact of type animal, or of type mammal? But we find that in fact the assignment does work. So then, with that being said, what is the point of confusion then? So if I were to say a messy animal, and I were to call a function in the messy animal, or messy mammal, sorry, and let's say I call the morning routine. This is the morning routine that I just created. Now, what do we expect? A messy animal is of type animal. We know the type animal has a morning routine, which is farting. And then we know a random mammal has a morning routine, and the mammal's morning routine is peeing. So what's gonna be the routine of our messy animal? Is it gonna be farting, or is it gonna be peeing? So if I compile this, we notice that it is farting, not peeing. And the reason it's farting is because during compilation time, none of the functions, so this transitions us to virtual and void. During the compile time, none of the functions in the animal class are virtual. And what that means is none of the functions, so that has relevance in this case because we notice that none of the functions are virtual. So since none of the functions are virtual, the function we are specifically calling is non-virtual, which means that the default function it's going to default to is going to be of the animal class. So that would mean it's going to default to this function in here. And that's because it's non-virtual. So for non-virtual functions, when an assignment happens, it's just going to look at the base class implementation. In this case, our base class was of type animal, and the base class implementation was the morning routine, which was farting. Now, an interesting thing happens when I make this virtual. And Yeah. So if I make this virtual and I run this, we notice now it does peeing instead of farting. And the reason it does that is because when you mark this as virtual, what you're telling the compiler to do is you're telling the compiler, when you look at this, any assignment that happens where a base class is being assigned to one of its child classes, if you're gonna call a function that is associated between the two classes, namely the morning routine, call the one that's on the right hand side of the assignment operation. So in this case, call the function that is part of the mammal class instead of calling the function that is part of the animal class. And yeah, that's it. So call the function that's part of the child class because the parent class is marked as virtual. So default to the function on the right hand side of the assignment operation instead of defaulting to the functions of the left hand side of the assignment operation. Okay, so now we talked about that. We talked about inheritance, and now we're gonna move into casting. So what does casting mean? So if we go back to our picture, we notice that there's two arrows. There's a downwards cast, there's an upcast. 90% of the time when I'm casting, it tends to be a downwards cast. Usually when you're dealing with frameworks such as Unreal, this tends to be true in that you have all these characters which are inheriting from an actor. So you have specific collision systems that are created, but they're created and they're set to fire only when two actors are interacting. So it's part of the developer's responsibility to say, okay, I know two actors are colliding, but what actors specifically are colliding? I know that they're two actors, but like, is it a character colliding with a coin? Is it a bullet colliding with another character? So we know that Unreal has created a system that handles collisions for us, or handles collisions in general. But it is sort of agnostic of the types that you're creating. So what it does is it just makes an actor class, and it makes everything inherit from the actor class. And then they have all the main implementations made in the actor class. When you're making the collision systems, it's implemented through the actor classes. And then it's your responsibility to downwards cast to make sure that the things that are colliding are in fact the things that you're wanting them to collide with. So let's go through an example to further illustrate what we have been talking about. So let's say I have an array. So I have a bunch of animals, and right now my mission is to create a vector, and then this is basically a list. You can think of this like a T array, and this list will store all the animals. Okay, I'm gonna add all the animals I've created from line 40 and line 43 and line 52. Basically create all those animals. Oh, I didn't create an animal here. I only created an animal here, created an animal here, and I created an animal here. And I know this because it's denoted by the new keyword. So I'm gonna take this, I'm gonna add this in my array. I'm gonna take this, I'm gonna add it to my array as well. I said add, but C++ is weird, and for some reason they decided that the add functionality should be called pushback. Okay, and we're gonna add one more to really complete the set. We're gonna do push_back. And what's the third one? our third one is Ken. I'm essentially looping through all the animals in my vector. That's what I'm doing here. Ooh. Okay. And what I'm gonna do is I want to cast it because let's say, for example, I wanted to know, I know that all the animals I know that I have all the animals in this vector. And I know that part of the animals that are stored in is an animal of type animal. So this line here, line 40. I also know a mammal is stored in here, which is in line 43. I also know that a wolf is stored in here, which is in line 46. And we know that this is possible because, as we've shown here, in line 52, we're able to assign an animal to something, to one of its child classes, because its child classes has all the functionalities that its parent class would have. So in this case, like when we said an animal could be a random mammal, a random mammal has all the functionality. A mammal has all the functionalities of an animal, so it would make sense that it would be able to be assigned to a variable of type animal, because it already has all the functionalities that an animal would have, if that makes sense. This has all the functionalities of this, so when I have a variable of this type, it should be, I will be able to assign it to either this, or I would be able to assign it to either this or this, because these two have the same functionalities as this. So yeah. And we notice we are using this concept in our vector as well, because we're assigning an animal, which is fine, that's the data type, but we're also assigning a mammal. So we're assigning a mammal into this vector, and it's able to be assigned. And we're also assigning a wolf, which is of type mammal. So now let's say I wanted to know in my array how many let's say I'm looping through my array, and this is something that's used a lot in game development. Let's say I want to know how many wolves I have in my array. Let's do that. So random wolf. To be able to do that, I have this dynamic cast _cast, and the thing I'm trying to cast to, which in this case is a wolf, and the thing that I want to cast. So I want to cast this random animal and see if it could be downcasted into a wolf. Can any of these member functions be downcasted to be this type? That's the main point. So if this cast fails, then this is gonna result in a null pointer. So we can catch that using an if condition. So we can say random wolf, and then from there we can say, so specific functionalities that a wolf would have. Let's just say he can bite, and then yum yum. Okay. So now I know for a fact that once I pass this if condition, the random wolf is in fact going to be a wolf. Because otherwise it wouldn't be able to execute. I have to do this if condition, because otherwise it would just crash if I just try to dereference it and call a function that is only specific to a wolf class, when in my array I don't have any wolf classes. So to further illustrate that, if I print this out and I run this, wolf bite has to be public. There we go. And run this again. Okay, so it says yum yum. So we know that it's executing this condition. This is one of the main topics of this, the most important topic, I would say. We have a vector of animals. We have 3 animals that are stored in there. And of those animals, one is of type mammal and one is of type wolf. We want to downcast to see if we're able to find an actor or a class or whatever that could be casted to a wolf. In our case, this is possible because on the 3rd iteration, we can tell it's going to first go through the first for loop. It's going to say, can a random animal be downcasted to wolf? That's not going to be true. So it's going to continue to the next iteration. Can a random mammal be downcasted to a wolf? That's also not going to be true. But then in our third iteration, where in line 59, where Ken we notice is in fact of type wolf. So we can downcast on our 3rd iteration when we're looping, when the random animal is equal to, so when the random animal, let me copy this. When the random animal is equal to Ken, then the random animal can be downcasted to a wolf, is what this is essentially saying. For example, there's like syntax error, but this is like what's going on. There's situations where the random animal that we have is in fact a wolf, or it has the functionalities of a wolf because it does store a variable of a type wolf, and we know it's a variable of type wolf because of line 47. And so when we're storing it in this vector, we know that we're able to get that variable through a series of downcasting, and once we're able to downcast successfully, then we're able to call a functionality that's specific only to that function. And that's the main takeaway of this video. The main takeaway of the casting portion of this video. So if you liked it, please hit like. If there was any confusion, let me know, and I'll get back to you as soon as possible.